Okay, ma'am. Am I audible, ma'am?
Yes, sir.
Okay, ma'am.
Welcome to the afternoon session. May I now invite Ms. Antoinette Luciana Sherin to introduce the chief guest. I take this opportunity to introduce and welcome our chief guest, Dr. Periyasamy Sundaresan, postdoctoral research fellow, Department of Technology, Education and Department of Biomedical Engineering, Chungnam National University, Republic of Korea. Sir has completed his undergraduation from the American College, Madurai, and post-graduation from Tyagarajan College, Madurai. Sir has pursued his doctorate in chemistry from National Taipei University of Technology, Taiwan, and completed his first postdoctoral fellowship from Chungnam University, Taiwan. His broad area of research includes electrochemistry, electro and photocatalysis, and sensors. He is well versed with various techniques in the CH instruments and has an extremely good handling of various instruments such as SEM, HRTEM, XRD, XPS, etc. Sir has numerous international journals, publications with the highest impact factor of 9.229 ACS Applied Materials and Interfaces. Sir has additionally presented his work in both international and national conferences. We are privileged to have such an eminent and versatile personality amongst us. Once again, we welcome you, sir. Over to you, sir.
Okay, thank you, ma'am. Excuse me. Okay.
The screen is not visible, sir.
Once again, ma'am. Once again, ma'am.
Yes.
Sorry for the late. Ma'am, please wait, ma'am.
So yes, sir, your presentation is visible.
Yeah, okay, ma'am. Okay. Can you see my presentation, ma'am?
Yes, sir. You can go for slide enter. Yes, sir.
Okay,
Yes,
okay.
it is visible.
Good afternoon, everyone. First of all, sorry for the late presentation. Okay. Am I audible, ma'am? Hello? Ma'am, am I audible to you?
So yes, sir, audible, but I think you should keep on holding the mic because கொஞ்சம் ரொம்ப sound கம்மியா இருக்கு.
Okay, ma'am. Okay.
Yes.
First of all, I'm happy to thank the management of Nirmala's Women's College And I would like to thank the head of the department and the program convener, Dr. N. Gunavati ma'am. And I'm happy to thank Ms. Cherin to giving me these wonderful opportunities to interact with our students. Thank you, ma'am. Before the presentation, I just remember to thank the God Almighties and my American College, Tyagaraja College, and the NTUT professors. This is the title, the nanostructure material for the electrochemical sensors applications. The major motto of this presentation is we have studied the many fundamentals of chemical properties and elemental properties, but we don't know what about the applications of the research field. So that studies, that presentation, I would like to connect both the fundamentals and the research applications because it is very useful for the UG and PG students' futures. That's why I select these titles. Are you audible, ma?
So yes, sir, it is going on perfect. No problem.
Okay, thank you, ma'am. Nowadays, the nanostructure materials are the most important and unavoidable material in our day-to-day life. It can be classified into the four different types, like the inorganic material, organic material, and the carbon-based material. The another thing is nanocomposite-oriented material. The carbon-based material is a major and the most great invented material is graphene. Graphene is the most important material for the many researchers like electrochemical sensors, battery applications, and it is applied in the many field. But the nanostructure material, the size, it means the dimensional is very important for the applications. So the nanomaterial is material. It's between the size 0 to 100 nanometer size. It can be exist in the various form like single and aggregated, agglomerated, and many forms. But it can be classified into the four types. The first one is zero dimensional, like the spherical and nano clusters are appeared in this dimensional. We have seen this structure. Uh, Only one surface can be appeared because no more surface are here. But compared to the one dimensional, it is better than the zero dimensional because here we are visible the most and clean surface, and compared to the two dimensional, we got better and higher surface area. Uh, we have see for the two surface, the front and back side. This is a two-dimensional structure. The like example is nano sheets and nano prisms. And the three-dimensional structure is a core shell and the nanotube-like structure. Here, we can visible the three surface area, the front, the X, Y, and Z. If we change the dimensional, this we get a more surface area. It is very important for the applications. That's why the many researchers are focused on the two-dimensional and three-dimensional structure-oriented material because it have a more active area, it get a more active sites, so reaction will be very fast compared to the zero and one dimensional. And another one, the metal tungstate. So metal tungstate is nothing but one of the metal oxides. Metal oxide is a compound between combination of active A cations and the active B cations with the containing of oxyanionic groups. Uh, Metal oxides and binary metal oxides also one of the alternative material for the carbon group. Uh, in recent time, many binary metal oxides are applied in the electrochemical sensor and the battery applications. But here I have focused on the metal tungstate material. Uh, Metal tungstate material, here I have focused for the three different type crystal structures like perovskite, chelate and the wolframite. The perovskite is we know AbO3 type group of crystal structure, and the chelate and wolframite is AbO4 type of structure. But AbO3 here, the active A cations are occupied in the corner of the cubes, but the B cations are occupied in the center of the cube, and the remaining active oxygen groups are occupied in the face center group. But the chelate and wolframite is little bit different, because here the active A cations and B cations are sharing to the oxygen group, but the wolframite is little bit different. Half of A cations and half of B cations are occupied with the oxygen group. Comparatively, perovskite structure is more optical and electrochemical properties for the sensor applications. That's why I have focused for the perovskite structures. Rare earth metal tungstate. We know very well the rare earth element is have a higher higher oxidation vacancies compared to the S block and D block element. The rare earth element group have for a more oxidation state. Uh, the common oxidation state is a +3, but the S block element is the +2, and the D block element is approximately +2 to +7 state. Uh, because the lanthanum group have for the lanthanum contraction effect. This effect is very useful for the get for more vacancies because the lanthanide contraction have a poor shielding effect. The shielding effect means the core shell of s orbital are pulling the electron towards the nucleus. That's why the atom size is decreases. So we get a more active area. It means more orbital vacancies. So that we get a trivalent cations. So compared to the S-back element, we get only for two valent cations, but the rare earth element, we can get a three valent cations group. So that's why I focused on the rare earth oriented metal tungstate for my application work. Uh, Here, many rare earth tungstate groups are applied in the supercapacitors applications, scintillators, dye-sensitive solar cells, and the laser applications, photocatalysis, electrochemical sensor, and the photoluminescence, and many applications for the rare earth metal tungstate groups. Uh, this application can be divided into the two type. The first one is a material synthesis and the electrochemical sensor applications. So previously we had discussed the importance of the metal oxides and the properties of the metal oxides. So that compared to the noble metals, the rare earth metal is cheaper than noble metals. That's why I have choose for the rare earth metal tungstate group. Then why should prepare the material for the applications uh, like pesticides. Pesticides is one of the chemical substance in the agricultural field. Nowadays, the agricultural industry is very challenging in our countries because the farmer need to spend more time, and the agricultural timing is timing and the product yielding is very difficult to get. That's why the farmer are selecting to use for the pesticide group. The pesticides can be applied in the three stages. The first stage is insecticide and the herbicide and the fungicide. The herbicide means uh, here we are seeing the rice plant. The rice plant, we have seen the unwanted herbs are present in the rice plant. It is uh, disturb the rice plant growth. That's why the farmers are choose for the herbicide. If the farmers is apply the herbicides, we can get more growth of the rice plants. That's why the farmer are choosing the herbicide group. And the second stage is a insecticide stage. It means after the plant growing, they get some crops or fruits. Here I have attached the corn plant. If the corn plant is grown well, but that time some insecticides are disturb the plant growth. That's why the farmers are choosing the insecticides. If they apply, the we can get a good product. uh, and another stage is a fungicide applications. This is a post harvesting stage, because nowadays many peoples are liking eye catches fruits and grains to buy the eye catches fruit. That's why the farmer and sellers apply the fungicides, because if the spray the more fungicides, it is very attractive to buy the fruits and rice, and it is prevents the fruits for the long time from the fungus, because our countries is a more populations countries. We need to give the food for the many people. We need to responsible for share the food for all peoples. That's why in our countries applied for the more pesticides in agricultural field. But we don't know how much of pesticides are applying in the agricultural time. Sometimes the farmer and sellers are across the limit, the pesticides limit. So that we need to monitoring the pesticide level is important for the application. This is a classification of pesticides. The four different pesticides are applied in our day-to-day life. The first one is a carbamate group, and second one is a organic chloride and phenylurea and the organic phosphate group. But the most important pesticide is a carbamate and organic chloride, because that pesticide is uh, most cheapest pesticide compared to the phenylurea and the organic phosphate. Here I have to select for the carbendazim monolite. This is for most important post-harvest fungicide uh, in an agricultural field. This is a functional group of the carbendazim. The NH group is a major functional group of the carbendazim. And the another one is a endosulfan. This is a functional group of the endosulfan O. And linuran. The NH is a functional group of linuran. And this is a methyl parathion. The nitrogen compound NO2 is a major functional group of the methyl parathion. The carbendazims are mostly applied in the rice and soya beans for the polishing and the seed pre-planting purpose. And organic chloride pesticides are mostly applied in the onion and tomatoes. Phenylurea groups are applied in soya bean. If they apply more in soya bean, the soil also affect from the pesticides. And organophosphates also applied in a long time. The groundwater also problem for. And the applications of carbendazim fungicides. The carbendazim is a most common fungicide in the seed pre-planting treatment and the post-harvesting purpose. It can prevent the fungal and inoculum on the surface of the fruits. It may protect the wounds that created at the harvesting time, and if they handle the fruits in very fast, it can damage the fruit. That's why they are applying for the more fungicides. This is a acceptable level of the pesticides, the 0.01 milligram per kilogram. If they take more from pesticides in per day, it is very difficult to the human health. But compared to the insecticide, herbicide, the fungicide is most dangerous one, because the insecticides and herbicides are naturally washable with the rains. But the fungicide is not washable because it is a post-harvesting uh, steps application. But most of the fungicides are sparingly soluble in water. So that's why we need to monitoring the fungicide is important. Effect of fungicides. If we take for a long exposed fungicide fruits in day-to-day life, it is very difficult for the human health, uh, like eczema, hormonal imbalance, infertility, hematuria, endocrine system, hypertension, and central nervous system problems are getting for humans. That's why the fungicide reduction is important. So determination techniques. Nowadays, various determination techniques are available. The first one is a high performance liquid chromatography and the UV detector. This instrument is a very sensitive method, but the instrumentation cost is very high, but the handling purpose is very difficult to all people. And this is for low specificity, and the cost effective is very high, and they need for high maintenance, and the reaction time is very slow, and it need for some sample preparation procedure. But compared to the electrochemical technique, they don't need any sample preparation procedure, and this is for a very cost effective method, and this is highly selective and user friendly method compared than HPLC method, and this is time consumable because it is very fast sensing manner. That's why I am selecting for the electrochemical sensor field. Introduction of electrochemical sensors. Uh, elec- Electrochemical sensor can be classified into the three different types. The first one is a chemical sensors and gas sensors and biosensors. The chemical sensors only applicable in the chemical analytes. Gas sensors, it can be applied in the detect the gas oriented compound, and biosensors is a affinity based sensor process. Here they are using for some biological group like enzyme and protein oriented group, but the electrochemical method is don't need any enzymes like a biological compound. These electrochemical sensors are classified into the four different types. The first one is a voltammetric sensor, potentiometric sensor, amperometric sensors, and embedometric sensors. Here I have chosen for the voltammetric sensor for my applications. Basic principles of the electrochemical sensors. This is a schematic diagram of electrochemical sensor process. This is a CHI instrumentation. This will be connected into the our system. Uh, this is a basic electrochemical cell setup. This cell setup have some electrolyte. This electrolyte is phosphate buffer saline using for the electrolyte. This electrolyte is containing a active electron carrier group. The electron carrier groups are uh, pull the electrons from analyte to electrode. If this starts a reaction, the electrolytes are carrying the electrons from analyte to electrode. Then we get a signal in our computer. Uh, Before the signaling, we get for some process like amplifications process. This is a uh, after the process we get a signal from the computers. This is for a working electrode like screen printed carbon electrode. This is a working area of the electrode. I'm already tell them the prepared electrocatalyst material will be coated on this surface. Then we are studying for the electrochemical sensor reaction of pesticides. The first work is structural insights on 2D gadolinium tungstate nanoflakes A promising electrocatalyst for the sensors of post-harvest fungicide carbendazim. The specificity of the work. Generally, the ABO3 type perovskites are attracting substantial attention due to the excellent electrical conductivity and the transport properties, and it is highly chemical and thermal stabilities. Especially the gadolinium tungstate possess exclusive properties such as low toxicities and excellent ferroelectricities. And here I have chosen a very simple method like the co-precipitation method. It is very advantage method because this is cost effective and rapidly, and they don't need any requirement and special conditions. The prepared gadolinium tungstate nanoflakes are used for the carbendazim reduction. This is a material synthesis schematic diagram. Initially, I have taken for the gadolinium nitrate. It's like a chemical substance, and the sodium tungstate group. We know very well in our laboratory, like is similar like so nickel chloride and copper chloride like substance. This is applied with the co-precipitation method for stirring at 1 hours in the presence of 50 degrees centigrade for 12 hours. In the presence of adding the urea, I will get for the gadolinium tungstate group, the ABO3 perovskite tungstate group. Before the product formation, we need to calcinating, we need to annealing for this product, because if we heat the higher temperature, the crystallinity will be increases because initially this is a macro size substance, but if we heat in higher temperature, the size will be decreases. We get a two-dimensional structure, but I will expect for three-dimensional structure, but unfortunately I get only for two-dimensional structure. The prepared structure will be confirmed with the various characterizations, and the catalyst will be applied for the electrochemical sensors like carbendazim detections. I get a signal from the CHA instrument. This is a first one characterization. The morphological studies of the gadolinium tungstate nanoflakes. After preparing the gadolinium tungstate, I just check with FESM and TEM analysis. The first one is a TEM analysis image. I have seen the nanoflakes like structures. We are seeing the flake structures appear. It means it have a two-dimensional structure. We get for two-side active area, so that the prepared catalyst will be applied for the electrochemical sensor. And this one is elemental composition studies. Here they don't have any more impurities because we are only present in the gadolinium, tungsten, and oxygen group like ABO3 group. Here the A means the gadolinium, B means tungsten, and the O means the oxygen group. And the crystallinity of the prepared catalyst are checked with the XRD analysis. Am I audible, ma'am? Hello? Ma'am? Hello?
Sir, yes, sir.
Okay, ma'am. Thank you, ma'am. Okay. This is XRD structures of the prepared catalyst. Here, the prepared catalyst are studied with the X-ray diffraction. In the presence of X-ray diffraction peak, if your compound is more crystalline, we get a more intense peak. Here, I get for more intense peak for the gadolinium tungstate group at 28.5 degree. and the prepared catalyst will be checked with the JCPDS file. It get a more crystalline structure, and the Raman spectra also confirm the presence of the element. Here, the AG symmetric stretching of the gadolinium oxygen group will be applied in the 765 and 395 peak, and the XPS is another structural characterization of the prepared catalyst. We don't know how much of impurities are present in the compound, but we need to confirm the element oxidation states. That's why I have choose for the XPS analysis. Uh, so here I get for the three peaks, the tungsten, gadolinium, and the oxygen. So they don't have any other impurities, and the gadolinium groups are deconvoluted into the 4D 5 by 2 and the 4D 3 by 2 at 142.3 and 147.5 peaks, and the tungsten groups are deconvoluted into the 4 of 5 by 2 and the 4 of 3 by 2 peak at 35.5 and 37.5. Similarly, the oxygen group also deconvoluted into the 530.2 and 531.7 and 532.4 and 532.3, which means confirm the presence of oxygen group. And another, I just go to for the electrochemical sensors applications. The first image is electrochemical activity of the gadolinium tungstate. We don't know how much of surface are present in the gadolinium tungstate. So we need to some reference group. So I just applied with the ferricyanide system. This ferricyanide system is for the redox properties. This is like a electrolyte group. If I check with my material into this analyte, I get a redox peak for ferricyanide, the oxidation and reduction peaks. If the get for higher peaks, higher peak intensities, uh, the the element have for more active size, and this is for various scan rate studies. If the scan rate is increases, the peak current also increases. This scan rate will be studied with Ranelagh-Civic equations. That equation will be helped to get for active surface areas. I just calculate from that equations, and the figure D is indicate that cyclic voltammetry figure of gadolinium tungsten nanoflake species at the 50 millivolt scan rate in the absence and presence of 200 micromole of carbon-tassim analyte group. I have hit two peaks at 0.82 volt and 0.6 volt. This is a major oxidation group, and this is a reduction group. Effect of scan rate and pH of the carbon-tassim is very important for the electrochemical sensor studies. That's why I studied with the various scan rate and pH. Here, the scan rate is increases linearly. They don't have any disturbance. The peak or linearly increases from the 10 to 200 micro millivolt. That's why it is get for adsorption controlled process. It means the reaction is only on the surface. The analyte and the materials react with only the surface, not for the diffusion control process. This is pH studies of the prepared catalyst. I have checked with different pH, the pH 3, 5, or 7, 9, and 11. Comparatively, the pH 7 give for more current intensities. That's why I have chosen for pH 7 for my all studies. This is the electrochemical mechanism of the carbon-tassim. The first one is carbon-tassim group. This is an active functional group of the electrochemical reaction. This is a two electron process reaction. initially the nitrogen groups are going to the oxidation state. It gives the nitrogen radical like Benz imidazole radical. Then the unstable, the intermediate Benz imidazole radical will be combined with the two groups, then get dimerization. The dimer will be reduced to form a alcoholic group. This is get a reduction peak. So this is a major oxidation peak of benzimidazole. This is a final dimerization reduction peak. The electrochemical determination with different concentration. The first image is studies with the various concentration of the carbon-10. If the concentration is increases, the peak current is increases, but the peak potential is slightly changed to the positive side because the pesticide is sparingly soluble in water, and if they go for higher concentration, it will be give some precipitation. That's why the peak potentials are changing. And the figure C is indicate that differential pulse voltammetric determination. This is a major electrochemical sensing application studies. It means if we check with a very low concentration to higher concentration, we get for the response because we don't know how much of pesticides are present in the fruits and food samples. That's why we have studied with various concentration. But in this prepared catalyst, the gadolinium tungstate nanoflakes give you a good response for the carbon-10 analyte. And selectivity studies is also very important for the electrochemical sensors because we don't know how much of unwanted interference groups are present in the fruit sample, because the fruits have some biological interference compounds like acids and another unwanted pesticides group also present in the fruits like diphenylamine and urea and carbofuran. That's why we have studied with selectivity studies. If we add with another compound, the electrocatalyst of gadolinium tungstate is more selective to detect the carbofuran analyte. This is a stability and reproducibility studies of the carbon-10 analyte in gadolinium tungstate nanoflakes. If I run with many times, the 1 to 15 times, I get a same current response for the carbon-10 analyte. And if I prepare for the electrode in 1 to 10 days, I get the same current response for the analyte. And this is a number of electrode repeatability test for the prepared catalyst. The 5 different electrodes are give the same current response for the carbon-10 analyte. So compared to the previous literature's work, the previous modified electrodes, the prepared gadolinium tungstate nanoflakes give a good response for the carbon-10 electrochemical sensors. It gives a 0.022 to 40 micromole of linear range concentration, and the lowest deduction limit is 0.005 micromole. This is another work for the electrochemical sensor studies. Is similar like the lanthanum tungstate nanoparticle and enhanced electrocatalyst for the selective electrochemical determination of anti-scald inhibitor diphenylamine. Here I have chosen for the ultrasonication method. The first one synthesis method is a co-precipitation method. That method is only applied for the magnetic stirring, but here I am applying for the ultrasonication. Initially I have taken for the lanthanum nitrate group and sodium tungstate group. Both material substances are mixed with water, and after the addition, the whole electrochemical mixture was placed into the ultrasonication bath at 60 degrees centigrade for 12 hours. In the presence of ultrasonication, it creates some bubbles, and the sonication, the sounds will be induced materials morphologies, it can enhance the the structural properties. After the sonication process, I will check with the different calcination process with the various temperature like 800 degrees centigrade for the 4 hours. Then I get a lanthanum tungstate nanomaterial. The prepared material will be applied for the electrochemical sensors. Similar like I have checked with the prepared catalyst for the XRD analysis. Here I get a 25.2 the major peak with a 2 to 1 plane. That peak will be confirmed with a JCF PDS5. The prepared catalyst will be confirmed for the perovskite like structure, the lanthanum tungstate group. After that, the lanthanum tungstate group will be checked with the Raman analysis. It will be give the symmetric and asymmetric stretching at 950 and 601. So it's confirmed the lanthanum and oxygen bond and tungsten and oxygen bond. And another studies is a morphological studies of the prepared catalyst. Here I have used it for the field emission screening electron microscopy technique for the morphology studies. In this material, give for the 100 nanometer size morphologies. This is a spear-like structures are appear. That's why I have mentioned with the nanoparticle-like structures. This is a impurity studies of the prepared compound. Here only present the lanthanum and tungsten and oxygen group. There is no impurities present in the prepared compound. The structural characterization of the lanthanum tungstate nanoparticles. The lanthanum group will be checked with the XPS analysis. Here the lanthanum groups are deconvoluted into the 853 3D 5/2 and 3D 3/2 group, and the tungsten 4F group are deconvoluted into the 4F 7/2 and 4F 5/2 groups, and the oxygen groups are deconvoluted into the 531.7 and 532.2 and 532.3. It means the lanthanum tungstate are formed in this oxidation without any other impurities. This is similar electrochemical studies for the prepared catalyst. The ferricyanide system will be confirmed the presence of active surface area of the lanthanum tungstate compound. This is a cyclic voltammetry studies of the lanthanum tungstate and nanoparticle for the diphenylamine compound. Here I get for the 5 different peaks. The first one here the 0.2 and 0.4 and 0.6 oxidation peaks are appeared, and the remaining 0.4 and 0 two reduction peaks are appear. The mechanism shown in here. This is a diphenylamine group structure. Initially, the oxidation, the primary 1 electron oxidations are appeared. That's why the NH groups are form a free radical group. This is a major oxidation group of this peak, the 0.6. After that, the group will be formed with a dimerization process. Then the dimer will be give the two peaks in peak 4,5 and peak 3,6. It means the diphenyl groups are present in apple group. The diphenyl is unstable group. If the diphenyl is present in the apple sample, it will be change into the radical. That's why the diphenylamine detection is important for the human health. Effect of concentration and scan rate of the studies. Here I have checked with the various concentration like 50 to 300 micromole of concentrations. If the concentration is increases, the current intensity is also increasing linearly. And the scan rate process here, the scan rate is increases linearly, but the peak potential is slightly shifted to the positive sides. Here in these conditions, this is not a absorption controlled process. This is a diffusion controlled process. It means uh, we already showed the electrode, the screen printed carbon electrode. The SPC have a electrocatalyst material, and the diphenyl is a analyte. The analyte will be diffused into the electrode surface. That means the diffusely controlled process. The first one reaction is only the adsorption control process. The analyte only absorb on the electrode surface. This is a difference between the first work and the second work. The effect of the pH and the determinations, I have checked with 5 different pH, but comparatively pH 7 is give you a high current response. That's why I have select with pH 7 for my work. This is a differential pulse voltammetric determination studies. I have checked with 0.12 and 1576.06 micromole concentrations. The concentrations are linearly increased and the current also linearly increasing. This is a interference and the selectivity studies of the prepared catalyst. I have checked with the various interferent compound, the similar pesticides compound like diphenylamine, diuran, carbofuran, carbentazine, and urea and sodium chloride, copper. Like in the presence of interference compounds, the diphenylamine give you a good response. It is not interfere. It is not disturbed with the other interference compound. This is a selectivity studies of the prepared catalyst. If we check with the first 2 and 15 cycle, the similar current response will be appear in this catalyst. This is a real sample analysis of the prepared catalyst. Here I have checked with the apple sample. I just collect with the apple skin and I wipe with the apple skin wax like the diphenylamine group. The diphenylamine group will be added with the electrolyte in the presence of the electrocatalyst connection. I get a response for the apple. The whole electrochemical studies will be compared with the previous literatures. The prepared lanthanum tungstate group will be give you a good response for the diphenylamine analyze. It gives you a 0.0024 microampere LOD, and the linear range is 0.022 58.06 linear range current response. This is a apple juice determination studies. Initially, I have added with the apple juice. After that, I just add with a known concentration of the diphenylamine group. I get a response, and this is a recovery value of the compound. The summary and outlook of the work. Here I have prepared 2 different catalysts, the gadolinium tungstate and the lanthanum tungstate group. This is a perovskite oriented material. This is rare earth metal oriented element. Compared to the other noble metals, the rare earth metal is a very cheaper material, and it can be easy to form a perovskite structure. And this AbO3 structure is a good active properties for the electrochemical sensors. Is similar like for the carbon group. That's why I am studying with the AbO3 type perovskite structure. This is the basic principle of the perovskite formation is oxidation state, and the oxygen on the cationic vacancy is very important for the perovskite structure formations. That's why I have selected with the rare earth element group for the material preparations. The both material will be prepared with simple synthesis method like the sonochemical method and the co-precipitation method. That both method they don't have any they don't need any more instrument, and this is a time consumable method for the synthesis procedure. And this synthesis material will be applied for the electrochemical sensor studies for the carbendazim and the diphenylamine. This method is highly reproducible, and successfully the electrochemical sensor will be attaining good results. The future perspective, this is a swiping and the touch sensor. Here they will be used for the electrode in the finger. Here they don't need for any electrochemical cell setup. Here they have for the electrolyte and the material and the analyte. If we connect with a mobile, we get a signal from the how much of analyte, how much of pesticides are present in the apple sample. This is for the very advanced and important for the future applications. If we check with the apple sample, like touch, we get a signal from in our phone. For the acknowledgement, I would like to thank the most MOST, the Ministry of the Science and Technology, for the research support for in this work. And I thank to my PhD guide, Dr. Chenming Chen, to giving me these opportunities for my PhDs. And I would like to thank Professor Taiyun Lee to giving me the permission to present in my official time. And I would like to share with the universities details in the Taiwan. Taiwan is most suitable country for the research students. This is a heart of Asia. The Taiwan have a mini institute. The familiar institute is a National Taiwan Universities and National Taiwan University of Science and Technologies and National Tsinghua Universities and NCKU, NTUT and NCTU. Here they are calling for the spring and fall semesters for the PhD students applications. I have studied in the National Taipei University of Technologies. This is most top universities in Taiwan. Many Indian students, especially women, are willing to study in these universities. In my PhD's time, many women are introduced to join in these universities. This country is a more comfortable and more respectable country for women. And this is a top universities in South Korea. Now I am working in South Korea. That's why I am showing these universities. The Seoul National University is a top ranking journal universities, and the KAIST and Chungnam National Universities and Yonsei Universities also top universities in South Korea. Compared to the Taiwan, the South Korea is have many opportunities in the postdoctoral research fellows. But if you interested in the PhDs, you can select in Taiwan is the best options for the research, especially women's. This is a basic scholarships of the Taiwan. Taiwan is giving two types of the scholarship. The first one is a Taiwan International Graduate Program. It's give for 34,000 NTDs per month for a whole 3 years. But another one is a Taiwan scholarship. It's give for the 2,000 NTDs per month. But here we need to pay the tuition fee. But the first type, we don't need to pay for the tuition fee. Now the Taiwan conversion rate is 2.7 for India rupees. This is I just share with my present working place. This is a Expo Bridge in South Korea in summertime. But now the winter time, we have see this like the snow-like structure. This is a Chungnam National Universities. Now the climate in South Korea is similar, like very freezing condition. I just share with the food is similar to the South Korea and India. The South Indian food like the urga is similar to the South Korea is kimchi, and the sweet pongal is similar to the yakshik, and our adai dosa is similar to the kimchi jian, and kolkatai is similar to the changpyeong, and elu mitai is similar to the yat yangjian. So both is culture is similar to our South Indian culture, and South Korea culture is similar. So we have many opportunities in Taiwan for the PhD students. If you contact with your professors and anytime, they are ready to helping you for your futures. So that's it. I have finished my presentation. Thank you for everyone.
Thank you so much, sir. The
Thank you, ma'am.
participants, the participants can pose their queries in the chat box, if any.
Okay, okay, ma'am. Okay.
The development of nanomaterials have proven fundamental for devising smart electrochemical sensors to be used in different application fields such as biomedical, environmental, and food analysis. The sensors show high performance in terms of sensitivity and selectivity. The structural insights on 2D gadolinium tungstate nanoflakes for sensing of post-harvest fungicide and simple sonochemical synthesis of lanthanum tungstate nanoparticles, which serve to be an electrocatalyst for the selective electrochemical determination of antiscald inhibitor diphenylamine, was quite interesting. Thanks for throwing light on the top universities in Taiwan and South Korea, which would help the young budding researchers look forward with dreams and hopes. Thank you so much, sir.
Okay. Thank you, ma'am.
Thank you so much, sir. Shall we wind up, sir?
Yeah, yes, ma'am. Sure, ma'am.
Looking forward to meet all the participants in tomorrow's session at sharp 9:30. I'm sorry. Looking forward to meet all the participants tomorrow sharp at 10:30 a.m.